I think, especially for we're just going to have a video. Okay, so we should have. We had 6 students. Oh, some one perspective. By the way, thanks to Ben Rocker, by the way, who was videotaping. You are on videotape, so don't say anything. As I learned the hard way, by the way, I say lots of things that you would think I would regret. I actually don't regret a tremendous number of them, but occasionally they do come to bite me in the ass, and I do regret the time I have to spend on. So in particular, I give a presentation at Google where I start off my presentation just like absolutely slaughtering this terrible book I read called Trivia and Code. Scott Rosenberg! Fuck you!
Have you read any other bad books recently?
That's a great idea. Any of the bad books. Any other piece of sorry, Scott, I'm sorry. It's the Mets. Sorry. I'm going to abide by the restraining order. Yes?
No, I was joking about the system tap thing, but I think as part of the dtrace education, it might be good to talk about the competition.
Oh no, I think that's a great idea because as we get more and more alcohol, that's going to
exactly. I think it'll just transition naturally.
Find me at about 10 p.m.
Yeah, that's right. I think the speech will be slurred, but the invective will be there, I guarantee. Okay, so let's get Jonathan, if I get the stool behind you, you bring that up here. And so that gives us 5 stools, and we get some chairs. So for this, I think we want, is it Andrew, is that right?
Yep.
Okay, Andrew definitely looks so Andrew and John Haslam for sure.
Brendan.
Brendan.
Network Brendan.
And I don't know what if any of you are going to want to do demos or what's that? Up here. Yeah. Okay, and other NOC4, you can speak to NOC4. And what other providers do we want to talk about?
We got NetFS, we got
Any providers people care about?
Yeah, well,
I have a Postgres provider.
Postgres.
Okay, so do you want to do the database? Do the database. No, we're talking about so we're doing like legacy hard providers and net providers.
You can also use this kind of providers that we like to see.
Yes.
So people can.
Brian, do you want to? Can you demo it? Can you demo it?
Yeah, definitely.
Oh, laptop pulls this where you can down.
Did I just power that off? That was I just reset like 4 times. No, that cable follows. So we do have, if you guys probably already figured it out, we've got Wi-Fi access. It's dtrace.conf is the network.
Yes, it does. Yeah. Bigger fonts.
Louder, funnier.
Yeah, we'll track down.
I can change the batch. I should run this.
about providers, is that right?
Yeah.
And a few of us can talk about the providers we've worked on. So I've worked on a few providers, including the network providers. The network providers I prototyped back in 2006 after I joined Sun as part of the Fishworks project with Brian. The code itself is fairly straightforward thanks to these three guys who have done a lot of the heavy lifting of providing the macros, and we just need to insert into the code. The difficult part about the network provider is deciding what to do, is deciding which interface we want to make stable, what arguments we want to commit to, what probes we want to provide. This has become even more difficult recently because we're not just doing this for Solaris, we're also doing this for other operating systems. So we don't want to embed any Solarisms into the network provider that will make difficulties when porting into Mac OS X. And I think that's what we've been striving to do. So what I can do is I can show you the current state of the network provider. I've got a few machines which have different versions of the network provider installed, so I can give you some demos as well. So let me just bring up the main website, which is on the Open Solaris page. So I'm struggling at the moment because I haven't changed this keyboard to Dvorak. How many Dvorak users are there in the audience?
Leave, all of you.
There's one? Wow. Thank goodness.
So actually, you can help settle a bet. How many speakers of Esperanto are there? I believe there are more speakers of Esperanto, maybe not in this room, but there are more speakers of Esperanto than there are Dvorak keyboard users. So Wikipedia, don't go to Wikipedia, by the way, no help. The Esperanto page was really, the Esperanto page and Dvorak page were both written by Esperanto and Dvorak bigots, respectively. So, of course, according to their numbers, there are billions of both.
10% of
Or speak Esperanto? Wow!
Dvorak. Amazingly, 10% of them are Russian. They overlap.
They may speak Esperanto. I'm saying ask the question.
Right, so the dtrace network providers.
Aren't you going to run a real demo? You're just going to show up.
The web page is where people can edit it, so this is the plan.
So Brendan,
Are you invited to teachers conference?
Brendan, can you hit Command plus a couple times?
also his head is kind of in the way.
Shake your head.
Someone get some movies. I just have to attend. I'll start with some demos. I'll jump into a couple of machines with the provider. So let me just bring that up. You can see how quick I am with Mac OS X. I'm still learning. Mac OS X, of course, is much more exciting now that we have dtrace on it. So good work, guys. Those guys should be here somewhere.
Still need to fix right.
Yeah, you can have your one issue.
Yeah,
Is that visible? You guys see that?
That's
Yeah.
Yeah, that's wonderful. Get a bigger font.
Good luck. That's it.
Let me write these down.
Like I said, I apologize for the slow keystrokes. When it's going to go through too much, I'll switch this into Dvorak mode, especially if someone can tell me now. So the providers on this operating system include IP, TCP, and UDP. And so since I'm connected over SSH, I should be able to begin tracing any of these guys. We should see some events. So let's do IP. I'm sure there are events actually happening. And so I can see send and receive. I do have a set of scripts that do work for this particular version of the provider. So what I'll do is I'll go through some of these as a reminder of which arguments happen there. This is one of, I've been through many versions of the network provider since 2006. This is one of them that include the TCP and UDP one, so it's a bit more interesting. So for TCP, it's especially valuable to be able to do things like except established. Except established. So what I'll do is I'll open up another tab and then connect to this machine. And you should see this probe, which is TCP except established, and I'm tracing to one IP source address. I should be able to see who's connecting to this machine. Tab. The font is really small here, you don't actually need to read it. I've made a connection, I don't need to complete that. And that's traced it. We've got the, so the actual probe name, which is the statement part, is accept established, and we have the IP address.
So, we're speaking about how the IP address is actually represented.
So this is IPv4, and it's a dotted point decimal. That's represented by inside dtrace. We can't go and call some of the other kernel functions to do this. So dtrace itself needs to, because it runs in a particular context, it needs to do all those string functions. So dtrace itself constructed that based on the 32-bit.
So the point is that it's a string. So this is something that because I think,
that's right.
correct me if I'm wrong, but this is an important design decision that you made.
That's right.
Was that having the IP address be a string? So no, we do not represent the IP address in terms of binary up to the dtrace consumer. And we were kind of trying to figure out how to do that. And we just realized, wait a minute, why don't you just represent the damn thing as a string? And then, right, exactly. And then you got, IPv6 and IPv4 just fall out. You got strings, and then you got all the dtrace string facilities, admittedly not documented.
How do you apply setter blocks?
What's that?
How do you apply setter matches?
Setter matches?
Prefix. Prefix.
Give me everything in this slide.
Yeah, can you say, can you give me 192.9.65?
We can't do that right now. What we could do is invent a function which knows how to take that string, convert it back. Exactly right. So, and that's how we do that.
And that just seemed to make more, because that way when you're aggregating on it, you don't have to, it was just a lot less information.
Yay, I can outside, I'm into brag. It's so hard to use queries. I do not know how you people put up with queries. Like it's simple things.
Brent will be giving the rest of the talk in Esperanto, so if you're not with an Esperanto speaker, you may want to move to your one.
Thank goodness. Sorry. Now, the main idea of the network provider is to answer customer-based questions. Very simple things like, who's connected to my box, what ports are they connecting to, how much traffic are they moving around. With dtrace performance analysis, I'm sure you guys have done some of this, the biggest performance wins are about eliminating unnecessary work. And network observability on many operating systems is not that easy. So how do you tell who's connecting to these ports, how much throughput is it by port? Generally you have to run other tools, including sniffers. They add their own overheads and complexities. This sort of thing is ideal for dtrace, to be able to switch on a dtrace enabling, let it run for 60 seconds and get your answer immediately. And especially using a lot of the dtrace capabilities to aggregate, print out distribution plots, say on network packet size, doing frequency counts of host names, doing the IP addresses which are represented as strings. All of that stuff is great. So you'll see that some of the stuff to start with that I can demo are fairly easy, and that's the point. It's to answer the easy questions and to get the performance wins that you get from the low-hanging fruit. So that was accept established. And there's things like TCP send. What I'll do is I'll run some scripts.
So things like that kind of use, for example, exact name.
So will exact name work for here? So that's a good question. Exact name won't work at this point because I'm at the TCP level and the network stack runs asynchronously to the thread that's on CPU. That's a difficult problem to answer, but it's also a very valuable problem. Which processes are causing the network traffic? So So I think if you've done a lot of performance work in Solaris 9, there are a few major questions that you really wanted answered. You wanted disk I/O by process easily, without having to play with TNF. You wanted network I/O by process easily. You wanted things like interrupt CPU time. Doing network I/O by process is difficult because the process itself is only on CPU when it's talking to the socket. So we can do that, and that's a big part of the network providers is preparing the metadata so that that question can be answered easily.
Usually follow the bouncing packet.
So is that the
Follow the bouncing packet.
So you say
follow the bouncing packet?
Yeah.
so prepare for a socket.
Prepare for a socket provider, that's right. So there is metadata that's passed through the stack as we start from the socket level and we go to TCP and then IP and then down to GLD. It's a matter of providing that as part of the interface so that we can use that as a unique key to trace all of these events.
Can you show your connection, the quantity that you were
So the quantity that isn't part of this provided, but I can certainly show you where it is on.
Oh, sorry.
That's
Oh, that's the okay.
and it does the pretty.
I think I had an incarnation of.
I did have an incarnation of this, so that's right. But I can show you where it was. So here's the master plan of the network providers. We have the probes, you can see in different protocols. One of the things we're trying to do, and if you're doing provider design for different probes, is to begin with the most consistent arguments so that they can be consistent across different programs. So the most consistent argument, the first one is packet info, and then we've got connection state info, which one just before. So if you've played a little bit with TCP/IP code, in Solaris anyway, there is something called the conteam, which is the structure to maintain information about a connection. And this guy's a representation, a stable representation of that for us to use so that we can trace network I/O by connection. So connections are things that generally TCP or SCTP. Packet info will be the identifier so that we can trace a packet as it goes through the stack at the different levels. And again, there are some things that sort of work for that right now. So when packets get passed through the stack, because the Solaris TCP/IP stack is still mostly streams based, that's an n block pointer, and you can sort of use that as a unique identifier. We have to standardize on that, so these can be provided.
Brendan, did you have to add additional information? You had to add some amount of measurement to the connection structure.
That's right. So to standardize on these two guys, we have to trace the points in the code where packet infos get replaced or a new, it's actually the streams end block. When that gets replaced or a new one gets inserted, so we need to actually keep an additional identifier. So each time the actual packet content in the kernel gets changed or manipulated, we're still retaining the identifier as this moves through the stack. If you talk to network engineering right now, is there anyone here from kernel network engineering? Yes. Okay, so that's one of the difficult things. It's
Show me your hand. He was going to say something really saucy.
anything you think about in terms of tracing networking will change. So I can't just find something in FBT and then use that as a unique identifier for tracing packet. That's what we'd love to do. There hasn't been.
Talk to me at a break. There's an interesting piece of work going on right now that has a pleasant side effect that works health traceability.
Okay, cool. And also, I'm talking to Eric Goldberg because.
Yes. Okay, you've already talked to him. Good.
Because this sort of thing should be in the plan for the big Solaris TCP/IP relay and moving ahead. So these things should be provided.
So, FreeBSD folks, Kinex folks, OS 10 folks, how do these things map? I mean, are you, in terms of, so I know you're not, you may not be networking expertise or networking expertise in your particular system, but is this implementable on so for these?
Well,
Kinex, you go last.
On that static plan, which they were actually city budget.
So these things are static probes, so it's STT additions. This TCP fuse I need to change because I changed it elsewhere on this website, but that's out of date. I've changed that to SDT because it is not, we guessed it doesn't exist on Mac OS X, and because of that, it should go. So that's one of the things we're doing, is we're going through this and we're making sure that what we're providing is going to work on other operating systems. And if you're using other operating systems right now, here's the question we've got for you. Can you provide, at some point in the future, a stable packet ID to trace a packet as it moves through the kernel? Like, we can't do this in Solaris right now. This will require a project to integrate that. And so the placeholder has been left in the provider. This will be null if that doesn't exist. The placeholder has been left if that work gets included.
And what is packet info? What is it? Pointer to data?
So that contains.
Do you have the translator, the actual translator? So it should be, it's important to mention that these are synthetic types. All those are synthetic types. So they are translated dynamically. So you don't actually need to have those types in your system. You just need to be able to generate a line of code that in D that can get from your internal goober to the synthetic type. So
we're going to stop and use your dtrace on that?
Yeah.
Just go to use dtrace and bring up something and use dtrace.
I'm getting the most recent version.
Okay, and we'll actually show some of the translators as well. This, by the way, I think the two greatest features of dtrace that get no attention, but I think are actually some of the more interesting ways in which we can advance the state of the art, are the translator mechanism that Mike invented, and the stability, the fact that we use programmatic stability, which no one cares about, but I think is awesome. So this is actually really pretty interesting. So there's the definition of IPM code. And go down to the translator. So here's the actual translator. These do not have to be perfect. In fact, they rarely are. Thank you, question mark operator. You can make these arbitrarily complicated, just about. And you can see these are a mess, but in terms of the implementation, that's okay. Because the point is that you're abstracting away so the user of the script doesn't have to deal with all this shit.
When you use the packet info.
So for packet info.
I'm sorry.
So right now there is this is a point to the raw packet structure, and the documentation says this is currently null. So the first thing on all operating systems, can you provide a kernel to the raw packet structure
In
at some point in the
VSDs, it
future,
will be
or not?
Unless it's changed recently, in VSDs that will be the MBUF
Cool,
structure.
that's fine. It doesn't matter what it is, because this is not.
It's a whole of NetBSD's stack. But the weird thing with Unix is that the whole stack is a user process.
Okay. So there are two members that would appear in packet info right now. One is an identifier, which is not listed in that struct, and the other is a pointer to the raw packet address. And the reason for each of them, the identifier, which could be based on the memory address of the buffer anyway, the identifier is so you can trace the packets that moves through TCP/IP. The pointer to the raw address is because lots of people keep asking me, can we detrace the contents of IP?
Yeah.
Can you
Tie it
separate
with
the
the package,
application
tie it with the
contents and do
package.
stuff with it? That's a tough question, because to actually reconstruct the application contents, that's very operating system specific. So for Solaris, you have to go and look n blocks and put them together. So I think what's
May have
most
changed halfway through going up the stack.
exactly. So what's most appropriate there is to provide the raw address, and then we can add a new action to dtrace, so that let's say packet data. You give it the raw address on your operating system, and that packet data function on Solaris, what it does is it walks n blocks. On FreeBSD, it does something else. On each operating system, it does what it needs to do to start with the pointer to the raw packet, and then give you the buffer containing the contents.
And that'll have, do you recreate that every time? Okay, let's say I detrace going up the stack, and I catch it first coming into IP to get demux. Oh, cool, it's a encrypted IPsec packet. And then I trace again later when it's demuxing to a TCP connection. It ain't gonna be an IPsec packet anymore. So I guess my question is the dtrace implementation code that parses the packet. I'm gonna have to do that every time I query for the data, aren't I?
Yes.
Okay.
And there's going to be some performance penalties there.
That's what I wanted to make sure people were aware of.
If you're doing content if you're actually interested in grabbing all the content, then you're going to hurt performance. Because with operating systems these days in 10 gig, you can be doing 100,000 packets a second. It's just a lot of data to simply copy, period.
Brendan, are we going to need internal enable probes to really make that reality?
So one thing that we may be able to help, and that's more to do with the overhead of adding instrumentation that's not enabled, is the dtrace is enabled kernel probes. So that's something that can help reduce the overhead of
if it existed.
If they existed. So there is dtrace is enabled for username, which is really cool, and that means you can do some expensive functions if dtrace is enabled. If you do that for the kernel, that can certainly help with that.
Shouldn't be too bad. I mean, we should.
Sure.
No, faster. No.
And Brad, I don't know if you have a demo of this, but I was wondering if you also want to mention that you did a prototype where we could actually, you added a write action, so you could write out the packet contents and then use Snoop's file format, so that Snoop would then do the decoding of the packet for you.
Exactly, and maybe I'll grab the workspace and then put it on the machine for later today. So one of the things I did was, because a lot of people have been asking me about detracing the contents of transactions, I don't like to answer a question without having prototyped it so that I understand that. I wrote a prototype of doing that so that it took that address and gave it to a function to give you the buffer contents. What I did, is anyone familiar with the Snoop file format? Or Snoop? Snoop is Solaris' version of TCP dump if you're on other operating systems. So it has a very simple format. What I was able to do is get a dtrace script to actually print the Snoop file format.
RFC 1761.
RFC 1761, thank you.
So because you should get to that with if printf can print binary, then you can do that with freopen, right? Freopen, the greatest function that no one ever calls. And then you can do that.
So yeah,
I don't know about freopen.
I can reconstruct this demo later.
That's the leak. Because of,
how many people have documented freopen?
Oh, wait a minute. Now my head's not going. Yeah, I'm actually document. Actually, no, it's a wiki now, man. That's not my problem anymore. That's your problem. That's your problem. All you people don't know about it because it's not documented.
It's documented in DT open.c.
DT open is pretty good.
That is the documentation in case.
So freopen actually allows you to specify a file name, and standard out then becomes the name of that file. And you can use that to, if you could print out the binary, you could do this using that.
And that's a destructive action, right?
What's that? That is a destructive action because it's destroying. It's an SE password, exactly. Yeah.
So I still have the dtrace script. I know this probably won't run because I don't have the workspace until later. But you can see that I've written some of the structures that's required for RFC 1761 into the dtrace. I'm looking at the dtrace script. So I have these guys. There's the Snoop version 2 record. Dtrace begin. I'm actually setting the magic number in the header ident. There might be a bit of way to that works.
So write is your binary.
And then I implemented a write action. And so for each IPv4 send from the IP provider, I was able to allocate the Snoop records required to actually output a Snoop log and put the details in and then print it out. And so you can actually, from dtrace, produce a Snoop log and then run Snoop minus I and actually examine the contents. That was interesting because we can look at different points of the TCP/IP snack and actually snoop different areas, like before IPsec. Of course, you're about to say this doesn't work in some cases.
No, I'm curious. Can I use that with the regular old FBT program?
You certainly can. So any of the additions, the translators, the actions that we're adding for this stable provider, if you know various points in FBT,
where I take an M block.
That's right. So you can just use them on there. So that would be handy.
Well, and that I think it brings up an important point in terms of when we're writing these providers, who they're for. Right, so these providers, the network providers, is a great example of a provider that is not for people who can do network. You guys got FBT and SE. This is for people, those of us lunkheads who are trying to actually understand networking. And I think whenever you're developing a dtrace provider, you should be answering for yourself the question: how is this helping to find a higher level problem, higher level software? The application that is getting nailed to death, the application that is just stupid in terms of the, it's C windows or those are the things that you really want to be able to find. And how do you develop a provider? Because implementers always have that BTS. these guys should really be.
And further to that point, creating points of instrumentation where you can actually act on the information you get from it.
Yes.
I mean,
what is actionable?
It can't be like interesting trivia, like, oh, I'm having, 10 quantums per, flux capacitor or whatever. But that's something that you can actually take an action on. That's what we're looking for.
Sorry.
So a couple of dtrace scripts that I'll be including in the first IP putback, and I've prepared an IP putback and it's with the network engineering team for code review, so I hope to put that back. I was hoping to get it done before this conference, but some of the network guys are unavailable, so that might happen next week. One of them is IP proto, again, something very simple to answer basic questions of what's happening now. Source address, destination address, proto, and count. If we look at this script, you'll see it's very simple, and that's the point of the network, is to make this as simple as possible. So,
Brennan's printf tracing and control C. Can we have a Brendan action for you?
You realize there's some wisdom behind this? If it says tracing, it means the script is tracing. If it says sampling, it's sampling. You should go and edit it and change the frequency of what you want.
And either one means your fucking keyboard's a Dvorak.
So tracing, we've got IP send and IP receive. For IPv4 and IPv6, the actual protocol exists in different structures. So for IPv4, that exists in IPv4 protocol. For IPv6, I'm just using the next header. Then I do a translation. So if it's, now these are all known to dtrace. So if it's whatever.
IP proto raw doesn't really exist. I'm a liar.
Which one doesn't exist?
IP proto raw. Just FYI.
Fair enough. And then we finish by printing it out in the
Use a
application.
global array for that. It'll be a lot more efficient.
We should use a global array.
And also, this is an example too, where in parentheses, it can make sense to add a function. If there's something that's going to be used all the time, you can add a D subroutine to do that for you.
The other simple script is IPIO. Here I'm looking at, this is kind of like a Snoop. But of course you can edit these scripts and add your own details of interest. We've got CPU, delta since the previous event, source destination, interface in bytes. And looking at that guy, fits on a screen, that's what it should be, very simple. IP send, print out stuff we're interested, IP receive, print out stuff we're interested, format it out. So that's the goal of these providers, is to make it as easy as possible without you having to take a lesson in TCP/IP and troll through operating system specific features.
Okay, so Brendan, that's great. I think if there are other questions for Brendan, I think we'll start next.
One of the manifestos.
Sure.
I think that's where we get all. One question though.
Sure.
For the meat cookie, can you tag that back to the proper one that's actually throwing the network traffic at you, or how are you going to tie this?
So the unique packet ID, I need to prototype exactly how that would work for a socket provider, and if that's something that we should commit to for all operating systems. Hopefully that will be available in the socket provider, so you can do a socket send and you can cache the exact name and process ID with a hashed array, and then later on you can print out the details.
And then vice versa for receive. You find out a packet's coming, and then you look for the receive in a process to match it up with.
That's right. For receive, you'll receive the event long before the thread is on CPU. So you need to wait until you've got those details and print them out. So it's going to require interaction with the socket provider.
Okay. Cool. Great, Brendan. Thank you. So I think there were some, for those of you who haven't written your own provider, some good quick object lessons in terms of how to write a provider. Having demos that fit in one screen, whether they say tracing, control C stop or not. Using translators to get into those higher level structures. You see that again in the NFS provider, and really focusing on what are the end user questions. I know that Alan Coopersmith, back in the room, developed the X server provider. That's another great example of a provider that's really designed to answer those higher level questions. Not how is the X server working, but what applications are pounding the shit out of the X server. Another good example of that.
So, guys, about the small version, would it make sense to have a gap print there and similar gap print day versions?
Yeah.
Right.